Hi friends, this is Shunila. In today's session, we are going to concentrate on an interesting topic, that is light. Okay, can you imagine the world without light? It is impossible. The rays from the sun is nothing but light. The rays from the bulb is also nothing but light. Hey, look here. The light rays are falling on the trees. How beautiful it is. Well, today we will understand the nature of light and its sources. As we all know that light is the form of energy. When we discuss its nature, a question comes into our mind, whether light is a particle or wave propagation. You know, various theories have been proposed to understand the nature of light. Let us have a look at each one of them. In the middle of the 17th century, Sir Isaac Newton has given a theory which is popularly known as Newton's corpuscular theory of light. Newton considered light is made up of point-like particles without any mass. He named these particles as corpuscles. Where do these corpuscles come from? According to Newton, these corpuscles are emitted by luminous sources. But first, tell me what a luminous source is. A luminous source is the body that can give off electromagnetic radiations. That is, light, such as the sun, a light bulb, etc. Other important aspect of corpuscle is that they travel in all directions in a single straight line. That is, they follow rectilinear propagation of light. Let me tell you what a rectilinear propagation of light is. Rectilinear propagation of light means the property of light to travel in a straight line in a given direction. One of the points is that for different dispersive media, the velocity of corpuscles is different. Newton, in his corpuscular theory, assumed that when light falls on the retina of the eye, it causes sensation of vision. Newton assumed that corpuscles in light are of different sizes. With this assumption, Newton concluded that various colors of the light are due to the difference in the sizes of the corpuscles. But tell me one thing, does Newton by his corpuscle able to explain the reflection of light? Yes, he did. But how? I will explain this to you by taking an example. Take a rubber ball and throw this onto the wall normally such that the ball hits the wall. You can observe that the ball bounces and returns in the same path. Now, throw the ball such that it makes a certain angle with the surface of the wall. The ball bounces and goes away from the surface of the wall, making an angle with respect to the normal drawn at the point of incidence O. So here, what we understood is the corpuscles of light behave like a rubber ball. Let's take a mirror. When a light incidents on the smooth surface, it gets reflected. The ray striking the surface of the mirror is known as incident ray. The ray getting reflected is known as the reflected ray. A normal, that is, the line perpendicular to the plane of the mirror is drawn. The angle between the incident ray and the normal is known as the angle of incident, and the angle between the reflected ray and the normal is known as the angle of reflection. Here, the angle of incidence is equal to the angle of reflection. The corpuscle also follows the same principle. That is, when corpuscles strikes the surface, they get reflected. When a normal is drawn, the angle of incidence formed by the corpuscles is equal to the angle of reflection. Does the corpuscle also follow the law of refraction? Yes, I will explain this to you. But let me first tell you what refraction is. Refraction is the bending of light as it passes from one substance to another. Let's check it. Here, the light ray passes from the air to the glass and back to the air. The bending is caused by the differences in density between the two substances. According to Newton, the corpuscle, when enters from the rarer medium, let's say air, and enters into a denser medium, let's say water, they are attracted near the surface and their speed increases in the denser medium, thus causing the bending. Hence, we can say that according to Newton, the corpuscles also follow the refraction. However, Newton's theory failed due to the following reasons. The speed of light should be greater in a denser medium than in a rarer medium. This prediction is contrary to experimental results. Hence, this point was proved to be wrong. Another assumption which proved to be wrong was that differences in the size of the corpuscles are not responsible for giving different colors of light. And finally, the phenomena of interference, diffraction and polarization cannot be explained at all. Now, let's have a look on wave theory of light. To understand, let's do an activity. Drop a stone in the pond. Here we can notice that the waves are traveling in all the directions. Look at the point where the stone touches the water source. At this point, the water acts as the source of water waves. Look, these water waves are in circular shapes. Do you know who introduced the wave theory of light? Yes, you are right. In the year 1668, a Dutch physicist, Christian Huygens, introduced wave theory of light. Huygens assumed that from a source, light travels in a form of waves. This is called as wave theory of light. Now, let me tell you what the postulates of Huygens are. According to Huygens, light propagates in the form of waves. For the propagation of light waves, material medium is required. For the propagation of a wave, Huygens assumed the existence of the medium called ether. The disturbances are produced in the surrounding ether medium due to the luminous source which sends out light energy in all directions. The disturbances produced in the ether medium travels in the form of longitudinal mechanical waves. In a homogeneous medium, the velocity of light waves is same everywhere. So, the disturbances reach all such particles at the same time. These particles are at the same distances from the source, and so they vibrate in phase with each other. The locus of all such particles is called wave front. Thus, we can define wave front as the continuous locus of all the particles of a medium that are vibrating in the same phase. A light source sends out disturbances, that is waves, in all the directions. The shapes of different wave fronts are spherical, cylindrical and plane wave fronts. Now, let's have a look at each one of them. A spherical wavefront is a wavefront originating from a point source. If the source of the light is in the form of a narrow slit, the wavefront originating from it has the shape of a cylinder. This is called a cylindrical wavefront. If the point source of light is at a very large distance, the radius of the spherical wavefront is very large, and a small part of this wavefront can be considered to be a plane wavefront. I can give you an example of plane wavefront. Light from the sun reaches the earth in the form of plane wavefronts. To explain the wave propagation of light, some very interesting examples were proposed by Huygens. The geometrical center or axis of the actual source of light, which is either a point or a line, is called the primary source, all points lying on small curved surfaces, which receive light at the same time from the same source, that is primary or secondary, are called wavelet. Any point on a wavelet acts as the source of light for further propagation of light. This is called a secondary source. The envelope of all wavelets in the same phase, having received light from sources in the same phase at the same time, is called a wavefront. The normal at any point drawn outward on a wavefront is called the wave normal. Further propagation of light occurs along the wave normal. Every point on the given wavefront is called primary wavefront, which acts as a fresh source of new disturbances called secondary wavelets that travel in all directions with the velocity of light in the medium. A surface touching these secondary waves tangentially in the forward direction at any instant gives a new wavefront at the same instant. This is the secondary wavefront. Thus, we can define Huygens principle as every point on the wavefront may be considered a source of secondary spherical wavelets which spread out in forward direction at the speed of light. The new wavefront is the tangential surface to all of these secondary wavelets. The progress of a wavefront can be studied with the help of a geometrical construction suggested by Huygens. If the nature of a wavefront at any instant is known, its nature and position at any other later instant can be determined. O is the point source of light in the air. C is the velocity of light in the air. Ct is the distance covered in the time t. ABC is the section of spherical wavefront at time t with center at O and radius Ct. A, B, C are the points on primary wavefront which behave like a secondary source. A1, B1, C1 are points on spherical wavefront with centers at A, B, C respectively. Surface A1, B1 and C1 are the new wavefront. The phenomena of reflection and refraction can be explained by applying Huygens principle. The velocity of light in denser medium is less than the rarer medium. According to Huygens, light energy is propagated as wave motion. Actually, at that time, Huygens didn't have any idea about wavelength and transverse nature of light. Then, who introduced the wavelength and transverse waves? Fresnel and Thomas Young introduced the term wavelength and transverse waves. He was able to explain the rectilinear propagation of light as well as diffraction, polarization and interference of light. Let us compare Newton's corpuscular theory and wave theory of light. Newton's corpuscular theory assumes that light consists of a stream of extremely small particles called corpuscles. Wave theory of light assumes that light travels in the form of a wave. In Newton's corpuscular theory, the rectilinear propagation of light is explained by the straight line motion of corpuscles. In wave theory of light, the rectilinear propagation of light is explained by the advancement of wavefront along the direction of normals drawn. Newton's corpuscular theory states that the colors of light are due to the differences in the sizes of corpuscular, whereas wave theory of light states that the colors of the light are due to the differences in the wavelengths. Newton's corpuscular theory says the reflection and refraction of light are explained by the repulsion and attraction of the corpuscles by the medium. But wave theory of light says the reflection and refraction are explained by the construction of secondary wavefronts applying Huygens Principle. Newton's corpuscular theory cannot explain the phenomena of interference, diffraction and polarization of light, whereas wave theory of light can explain the phenomena of interference, diffraction and polarization of light. Newton's corpuscular theory predicts that the velocity of light in a denser medium is greater than in a rarer medium. However, wave theory of light correctly proves that the velocity of light in a denser medium is less than that in a rarer medium.